Diving into the icy depths of the Pacific Ocean, researchers stumbled upon a perplexing phenomenon when they descended 13,000 feet below the surface. At this extreme depth, something entirely unexpected occurred: the oxygen levels spiked dramatically. This was a complete surprise, as the researchers were surrounded by an almost impenetrable darkness, a place where conventional knowledge suggested oxygen production should be impossible. It was at this moment that the team realized they had uncovered something unprecedented: dark oxygen. This extraordinary form of oxygen, created in the frigid, lightless abyss of the ocean, could have profound implications for our understanding of life's origins on Earth. Even more intriguing, it may lead to the discovery of life on distant planets. This groundbreaking revelation was made entirely by accident. Our exploration begins in the Clarion-Clipperton Zone, a vast, underexplored region of the Pacific Ocean that stretches across an area larger than Mexico. This part of the ocean is one of the most mysterious and least understood regions on the planet. When scientists plunged to the very bottom of this zone, they encountered something odd, peculiar: potato-shaped mounds, scattered across the ocean floor. These seemingly insignificant formations are known as polymetallic nodules, and though they may look unremarkable, they are like treasure troves waiting to be unlocked. Over millions of years, metals dissolved in seawater accumulated around small particles of shell or debris, forming these nodules. Inside them, researchers found valuable metals such as manganese, nickel, copper, and cobalt. These metals are essential for many modern technologies, including the batteries that power our smartphones, electric vehicles, and renewable energy systems like solar panels. The immense potential of these metals has made the Clarion-Clipperton Zone a focal point for deep-sea mining. As of today, 16 deep-sea mining contractors have been granted permission to explore around 20% of the zone's seafloor, turning it into a hotbed of industrial interest. The unprecedented rush to tap into these resources has spurred both excitement and concern. As companies deploy advanced underwater vehicles to mine these resources, researchers have become increasingly curious about what lies beneath the waves. Using state-of-the-art technology to collect sediment samples from the ocean floor, scientists began uncovering unexpected and puzzling data. Instruments showed something that defied logic: large quantities of oxygen were being produced on the seafloor, deep in total darkness. This discovery was shocking because it directly contradicted what scientists understood about oxygen production in the ocean. The deeper you go in the ocean, the scarcer oxygen becomes. By the time you reach depths of around 3,000 feet, oxygen levels are so low that life is barely sustainable. At these depths, the water is too far from the surface to exchange oxygen with the atmosphere. Moreover, the remaining oxygen is constantly consumed by the microorganisms and bacteria that inhabit the deep sea. So, when researchers found evidence of oxygen being produced at 13,000 feet, they initially dismissed it as an error. They assumed that their instruments were faulty, as every prior study in deep-sea environments had only shown oxygen being consumed, not produced. However, after repeated measurements over 10 years, the results remained consistent: oxygen was being generated deep beneath the ocean's surface. This realization sparked a flurry of investigations, leading researchers to a revolutionary conclusion: the polymetallic nodules, scattered across the ocean floor, were producing oxygen through a process that had never been observed before. The nodules, it turned out, were behaving like natural batteries. When submerged in seawater, they generated electric currents that were strong enough to split water molecules into oxygen and hydrogen in a process known as electrolysis. Here's how it works: when you place a battery in seawater, electric currents cause the water to break down into its component elements, hydrogen and oxygen. Normally, this requires a certain voltage to occur. The nodules found on the ocean floor carry an electrical charge of about 0.9 volts, not quite enough to initiate electrolysis on their own. However, when these nodules cluster together, their combined electrical charge can exceed 1.5 volts, the threshold necessary to trigger the reaction and produce oxygen. Essentially, these clusters of nodules were generating electric currents, strong enough to split seawater molecules and create oxygen, even in the total absence of sunlight. This finding is nothing short of revolutionary because it challenges one of the fundamental assumptions about life on Earth. Up until now, scientists believed that oxygen could only be produced through photosynthesis, the process by which plants, algae, and other organisms convert sunlight into energy and release oxygen. But in the pitch-black depths of the Pacific Ocean, oxygen was being produced without sunlight, purely through electrolysis. This previously unknown form of oxygen production, dubbed dark oxygen, has the potential to rewrite our understanding of how oxygen can be created and sustained in extreme environments. The implications of dark oxygen extend beyond Earth's history and into the realm of astrobiology. One of the greatest questions facing scientists today is how life first emerged on Earth more than 3 billion years ago. Oxygen-breathing organisms, such as animals and plants, require oxygen to survive, but it has long been a mystery where the first oxygen came from. If plants produce oxygen through photosynthesis, what came first, the plants or the oxygen? This classic chicken and egg dilemma has baffled scientists for decades. The discovery of dark oxygen, however, provides a potential answer. If oxygen can be produced in total darkness through electrochemical processes, then it's possible that early Earth had a source of oxygen long before photosynthetic life evolved. This could have allowed oxygen-breathing life forms to thrive even before plants and algae became widespread. But the significance of dark oxygen doesn't end there. This discovery also opens up new possibilities for the search for life beyond Earth. If oxygen can be produced without sunlight in the deep ocean, it could also be produced in similar environments on other planets or moons. Take Saturn's moon Enceladus or Jupiter's moon Europa, for example. Both of these moons are believed to have subsurface oceans hidden beneath thick layers of ice. Could dark oxygen be generating oxygen-rich environments in these distant oceans? If so, life could potentially exist in places we previously thought were inhospitable. Dark oxygen challenges our assumptions about what conditions are necessary for life and forces scientists to rethink how they define habitable environments in the search for extraterrestrial life. As exciting as these possibilities are, it's important to remember how this story began, with deep-sea mining. The rush to exploit the Clarion-Clipperton Zone's rich mineral deposits has sparked significant concern among environmentalists and marine biologists. While mining these valuable metals could play a crucial role in the production of clean energy technologies, such as electric vehicles and solar panels, it could also have unintended consequences for the fragile ecosystems of the deep sea. Polymetallic nodules are not just passive lumps of metal, they are actively participating in the chemical processes that shape the planet. Mining these nodules could disrupt the production of dark oxygen, potentially endangering marine life and upsetting the delicate balance of the deep-sea environment. The Clarion-Clipperton Zone is home to a surprisingly diverse array of deep-sea creatures, many of which have never been officially identified by science. About 90% of the species living in this region are unknown to researchers, meaning that we have little understanding of how deep-sea mining could impact their habitats. From ghostly white sea anemones to deep purple sea cucumbers and tiny marine isopods, the creatures of the deep sea are as mysterious as they are fragile. As a result, scientists are calling for more research and greater caution before we fully commit to widespread deep-sea mining. This remarkable story of discovery, from dark oxygen to the potential risks of deep-sea mining, is just one of the many incredible topics we explore here at Waves Discovery. If this journey into the unknown has sparked your curiosity, be sure to stay with us for more groundbreaking stories that delve into the mysteries of our world and beyond. There's always more to discover at Waves Discovery, where we unravel the wonders of science, nature, and the universe.